Hello YouTube. This is a video response to, let's see, Redshift Science. He was slamming Everett's vlog big time, and I'd like to defend a lot of what Everett has been saying. First of all, the part about infinity. Sure, as far as we can tell, there are no physical infinities. That's not incompatible with saying, there are. It could be that that the universe, that there is an infinite amount of space-time, that space is infinitely large, and that we just don't know this. As far as we know, that could be the case. It might be false. There could be reasons for why that's physically impossible. But still, as far as we know, the universe could be infinite. I also suspect, largely due to quantum mechanics and how it's successfully quantized a lot of things, that there are no physical infinities. But, again, there still could be, as far as we know. You gave a philosophical interpretation of the Planck length. I mean, some people interpret the Planck length as being, yes, like the smallest possible distance. That was something you claimed, and yes, some people agree. You didn't really justify that, and you can't justify everything in a 9 or 10-minute video, so I understand. Another thing, you said that it doesn't even make sense to talk about physical infinities. That is false. I mean, it appears to be physically impossible to travel faster than the speed of light. It certainly seems impossible to travel infinitely quickly, but it's not like that's incoherent. There's no contradiction in talking about someone traveling at twice the speed of light. You just can't physically do it. Another thing, okay, so even suppose that the universe is finite. Now, Michio Kaku asks us to talk about, Michio Kaku, I'm sure you've heard of him, theoretical physicist, written a lot of books on popular science, he's a string theorist, but first of all he says, okay, let's stop thinking naively about the world as like a big box, that has a center. There is no middle of the universe. I know you weren't saying that, but just part of what Kaku was saying. There's no middle. It's really more accurate to think of the universe as the surface of a sphere. There's no middle of the surface. Like, every point is the same as every other point. So, okay, suppose that it's correct, or that it's accurate to model the universe as the surface of a sphere. Well, if you were traveling infinitely quickly, then you'd be traveling along a great circle. You know what I mean? Like you probably know what that means. So you could travel along a great circle, say, and sure, it's really weird to think that if you were traveling infinitely quickly, that you would be, what does that mean? You'd be in two places at once. I mean, it's really weird to think about what that entails, about traveling at an infinite velocity entails, but it's not incoherent. And it's also not contradictory. Again, yes, it certainly appears to be physically impossible. That is very different from saying that something doesn't even make sense. Okay, you talk about Popper a little bit. Within the philosophy community, he's largely considered the most overrated philosopher of science that ever lived. A lot of scientists believe that they buy into what Popper said, but no, a lot of people just like falsification. They don't know all the problems associated with it. I'll go into what is one of the most serious challenges for it. Karl Popper also was skeptical about confirmation, so he thought that you could, so Karl Popper would say, okay, look at quantum mechanics. It's given us accurate predictions over and over and over and over. But Popper, because he is skeptical about confirmation, just by definition what that means is that he doesn't think that quantum mechanics is any more likely to be true, even given the fact that it's been accurate so many times. He just doesn't think that it's, you know, more likely to be false. He thinks that's as strong a statement as you can make, given all the accurate predictions. You had a bizarre inference in your video. You said that Everett hasn't explained away Popper's falsification schema, therefore Everett hasn't addressed the problem of induction. Let's see, I'll link you to one of my other videos where I went into perhaps a little bit more detail than Everett about what the problem of induction is exactly. I mean, sure, ultimately, you know, Everett's right when he's saying that we have not justified induction, or it's not clear that we're rational in using induction. It's not clear that anyone is given a non-circular justification for induction. But yeah, I mean, you could say, oh, it's, you know, there's problems with induction because no one has, you know, fully justified it. But anyway, I went into more detail about why it's a problem in like I said, in one or two other videos I made about this. I'll put it in the video description.